Hello, now I am going to teach you the construction of three-phase induction motor. I hope you all will enjoy learning this. Uh, Actually, as every motor, this three-phase induction motor also have two types of parts, that is stator and rotor. Okay, as we know that S stands for stationary, so stator is a stationary part and rotor is the rotating part. Okay, so as already I mentioned the previous videos, this three-phase induction motor does not have any magnetic poles. So both stator and rotor has its slots. So what do you mean by slots? Means slots is like a box where we can fix our windings. Okay, so generally so we have here in this diagram also it is mentioned, that is the outer this is a stator. Inside here it is mentioned there is slots, so these are all slots. It's like a box, like if you have a pencil box you can keep the pencils inside. The same way, like a pencil box, we have a slots, and inside the slots we place our windings. Okay, so we place the windings, so this is how it looks. Okay, and now coming to this different types of the slots. So we can have this three-phase induction motor can have three types of slots in it, that is fully open type, fully closed type, and semi-closed. Okay, so this slots can have this types. So generally you just think, suppose if it is a fully open slots, what are the advantages and disadvantages? Like suppose if I place a winding in the slots, since it is open, now this is a stator slots, now we have a rotor, and in between we have an air gap, so we may have the magnetic field interference. Okay, so due to this open type. And another point is that if any mechanical vibrations happens, so in that mechanical vibrations the winding can easily come out. Okay, and these are the disadvantages. But what is the advantage is that suppose if we keep a winding inside it, if there is any fault occurs, since it is an open type, the repairing is very easy. Okay, the identification of fault is also very easy. So this is about the open type. Now what about the fully closed type? So this is a fully closed type. So in fully closed type slots, what happens, we place a winding here. The advantage is that unnecessary magnetic interference will not be there, and any mechanical vibrations, the winding will not come out. Okay, but one disadvantage is that if anything happens inside the winding, the identification of the faults and the repairing, opening of the slots is difficult as compared to the previous one. And the third one is the semi-closed. In semi-closed, what happens, since we have this winding and partially it is closed, so the magnetic interference is restricted, and under vibrating conditions the coming out of the winding is restricted, and the repairing is also possible, the identification is also possible. So generally we choose the semi-closed type of slots. Okay, so this is about the types of slots. And we should know the what are the materials used for this stator. So this stator is used for, we use some materials, like what are the materials we can use: silicone steel, cast iron steel. So the materials which are having less magnetic losses, we try to use them. Okay, so coming to the stator, what are the conclusion? It is a stationary part, it has the outer coverage, and it has a number of slots. In the slots we place the three-phase winding. So what is three-phase winding? As already mentioned, three-phase winding means it is just a 3 wires. Okay, if I say 3 wires, you can see that the wire is not as 3 wires. Here we have the multiple strands. Like suppose if it is a R phase, if I need this much is the length and this much is the area of cross section, so according to this, length will be same, area of cross section. In this area of cross section, instead of making it as a single wire, that is, suppose if I need some x area of cross section, the same area of cross section, instead of using a single wire, suppose this is a need of wire, we use very small wires like this. see here. So same uh, length and same area of cross section, but instead of a single piece we have a multiple strands. Okay, this is due to avoid some magnetic losses like hysteresis loss and other losses as well. Okay, so now as per the construction is concerned, so this much is sufficient. Okay, so we have a three-phase windings. Now when we compare to this all the three phases, the three wires are identical to each other. The voltage magnitude is same here, same here, same here, and the current passes through this one, current passes through this one, current passes through this one, all are same. Then why do we call it as a three phase? The why do we call is the reason, because the voltage and current in these three phases are displaced by an angle. Okay, that is 120 degree. Each phase is displaced by 120 degree. Suppose if I talk about R phase, if I talk about Y phase, if I talk about B phase, if this is the voltage V1, if this is V2, if this is V3, so V1 and V2, then V3. So all these voltages are displaced by 120 degree. Then that's the reason we call it as a three phase. So these three wires are wounded as a winding like this, and that winding is placed in the stator core. Okay, so that's all about complete stator. Okay, we saw about the type of slots, and we have seen the types of winding, how does it used, and three-phase winding, how do we place it. Okay, now coming to the rotor. Just a minute. The next one we are going to see about the rotor constructions. Okay, so the rotor construction is also consists of slots only. Okay, the rotor construction is also consist of slots. So it will be having slots like this, but instead of having winding like a stator, instead of having a winding, we have something different here. Here what do we call is, instead of having a winding, we have, this is a stator and we have a rotor, and we use the copper bars. Okay, that is we use copper bars. You can see it here, these are the copper bars. Okay, so these copper bars are using a winding, these copper bars are connected. Okay, by means of copper strips, these are interconnected like this. Okay, so it can make a complete winding. Now the important point, one point I am going to tell you, that suppose if I start making a connections. Okay, now here we have see here, this is called copper bars. Okay, let's say I'm going to start from this point, I'm going to connect it. I'm connecting here, I'm connecting here, connecting here. So like this we are connecting the copper bars. After connecting, so here these two are, this is a starting point, this is the ending point. So here the point is that whether these two are also connected or these two is open circuited. Okay, so whether these two are connected or open circuited. Now if by using this type of connection, we can divide this induction motor into two types, that is squirrel cage and a slip ring induction motor. That is just by knowing this type of connection. So these two, the starting and ending point, we can call it as a end rings. Okay, end rings means because it is starting and end points, so end rings. So if the end rings are connected, it means closed circuit. Okay, this rotor is closed one. Okay, so if it is closed, the end rings are already short circuited. Okay, then it is called squirrel cage induction motor. Okay, so it is squirrel cage induction motor. Now in squirrel cage induction motor, what will happen? What will happen is, since the circuit is closed, what happens is, one option will be blocked for us now. How? In case, suppose if I want to do a speed control, okay, if I want to do a speed control, how do we do the speed control? How to do the speed control? The speed control we can do by changing the resistance value. How? If we know the current is equal to V by R, by changing the resistance value we can change the current. By changing the current we can change the flux. By changing the flux we can change the torque. By changing the torque we can change the speed. Okay, that is speed. Okay, so by changing the resistance, even in normally in home we have a ceiling fan. How do we control the speed? That is 1 2 3 4 5 speeds we have. How do we control? By using we have a regulator, so where we change the positions. Actually, what do we do there? We actually change the resistance. So by changing the resistance we do the speed control. We reduce the speed, we increase the speed. Okay, decrease and increase the speed. So in this case, in the squirrel cage induction motor, since this end rings are closed already, since this is closed, this option is closed for you. Because if this is closed, you can't insert any extra resistance. You can't change the value of this rotor resistance. So this is called squirrel cage induction motor. So in squirrel cage induction motor, if you want to change the speed, you will not be able to do from rotor side. So note this point, I am not saying you can't do speed control even from the stator side. I'm just telling you only one option is closed, that is we can't do a speed control from rotor side. Okay, since because there is no option, there is no provisions, okay, for connecting any external resistance. But in case of slip ring induction motor, so what are the opportunities we are having? In slip ring induction motor, these end rings are not connected, it is open circuited. Okay, so now this, see these are all connected, but this end rings, this is not connected, it is open, so this is connected to the slip ring. Okay, this is kind of slip ring we'll be having. So in the outside we have 5 terminals, that is for giving the supply R, YB, that is 3 phase, and apart from this you can find S1 and S2, but not in case of squirrel cage. So this S1, S2 is the slip ring, and S1 and S2, that is the end rings are connected. So what you can do even in laboratory, when you do, just to give the 3 phase supply here, and now in the S1, S2 you may connect a rheostat. Okay, when we connect this rheostat, here when we connect the rheostat, what we are doing, so this is only S1, S2, this is only S1, S2, and here when you are connecting the rheostat, indirectly you are connecting this rheostat with the this S1, S2, this S1, S2 connecting in series with this resistance of the rotor. So indirectly what we are doing, if this is a rotor resistance, by connecting this, suppose this rotor resistance is having X ohm, and let's say this you are having Y ohm, so you are adding X ohm with Y ohm with X ohm, so you are increasing the resistance value. So by increasing the resistance value, as I told, the same actions will happen. By increasing or by decreasing the resistance value, what is going to happen? The current will affect, and due to current, all the parameter will change, then the speed control is possible. Okay, so in squirrel cage induction motor, the speed control from the rotor side we can't do because the end rings are closed, but in slip ring induction motor the end rings are open circuited, so we can connect the external resistance by which we can achieve the speed control. Okay, so this is a point you have to understand by this rotor construction. See here, you can see how the slip ring is looking. Okay, so here it is, so this is called slip ring. Okay, so the end rings are connected. Now one more point we have to see this. See this is the slots, this is the rotor slots. We generally see it is straight, but you can see that instead of straight, it is inclined. The slots are inclined. Okay, inclined. So why it is inclined? It is very important point. You may even in laboratories, if you have any viva questions, the external may ask the same question to you, that we have a stator and we have a rotor. Stator has the slots, rotor also has the slots. Stator is carrying a winding, rotor is also carrying a winding. Stator is carrying a magnetic field and this rotor is also carrying a magnetic field. So what happens is, now here we give supply, and this supply, due to this the flux produced, and this flux cuts the magnetic field, cuts the rotor, and EMF is induced by which the magnetic field is created. So approximately this flux and this stator flux both are equal in magnitude, I mean equal in force. So what happens is, there is a condition, since if suppose if the stator slots and the rotor slots both are parallel to each other without any inclination, if there are if the both the slots of stator and rotor are parallel to each other, what happens, the magnetic field produced by the stator, the magnetic field produced by the rotor, both will under the locking, that is magnetic locking condition. The rotor will not be able to rotate. Okay, it is under the locking condition. So to avoid that, what should we do? So the rotor flux, the rotor magnetic field should be little bit inclined with the stator flux. So in order to get this inclined flux magnetic field, we make the rotor slots, we make this rotor slots inclined, not exactly parallel to the stator slots. That's the reason when we look at this rotor slots, always it is a little inclined. The name of that type of slot is called skewed slots. Okay, so if someone asks what do you mean by skewed slots, means making the rotor slots inclined to the stator slots is called as skewed slots. The reason it is made it in such a way to avoid magnetic locking condition. What is magnetic locking condition? The rotor will not be able to rotate due to the equal amount of magnetic field by the both the stator and rotor. So there, due to this, the both the force get cancelled each other and there won't be any force. Then the rotor will not be able to rotate. Okay, so this is another point of construction in case of rotor. Okay, so here you can see the complete induction motor will be looking like this only. So here we can see this is the terminal box where you give the three-phase supply. Here for squirrel cage you can see only RYB terminals, so just simply connect the RYB, and for slip ring you can find out RYB and S1 S2. And now this is the stator, and here these are the slots and windings are kept, and here we have a rotor and it is having a skewed slots, and this will be the outer coverage. Just simply this rotor is inserted inside, then it is a complete motor. Okay, so mainly these are the points you should understand with respect to constructions. So remaining topic we'll see in next class, next lecture, next video. And thank you. If you like this video, please subscribe and share. Thank you.